Previous class, what we discussed about is relational database. So what is relational database? Then we come back with some rules of a DB, what you call as relational database, that can be applied for a table, right? So we discuss about domain constants. So various data types that it contains to define a particular attribute of an database, Then I comes with a keys. So various types of key constants have been discussed, like what is super key, what is candidate key, what is primary key, and what is the secondary key has been discussed. I told super key is nothing but a combination of attributes that uniquely identify a tuple in relation is called super key, right? Then I comes with a minimal set of super key can be called as candidate key, I told, right? Then I told about one of the candidate key can be called as primary key. Then other key which is other than primary key is called secondary key. Okay, so that has been discussed with us, right? Then we comes up with the foreign key, where I can tell that an relation attribute of relation R1 refers to the primary key of relation R2 is called foreign key. Right? An attribute of a relation R1 refers to the primary key of relation R2 is called what do you call as foreign key. It's called foreign key. Right? That has been discussed. That has been discussed yesterday, right? Then I told that entity integrity and referential integrity. I talked about constants, where I told that primary key cannot be null. The rule is defined is called entity integrity constants. It's called an entity integrity constants. We told that entity integrity constant is that primary key cannot be null. It can tell that primary key cannot be null, right? Then referential integrity constants, where I told that a tuple of an attribute of relation R1 refers to the primary key, refers to the existing tuple of relation R2 is called a referential integrity constant. Okay, a tuple of an attribute of relation R1 refers to the existing tuple of relation R2 is called referential integrity constants. We call as a referential integrity constant, right? So this is what we discussed in yesterday. Last class we discussed about all this one, right? So entity integrity means the rule must be defined that primary key cannot be null. Referential integrity means where I told that a tuple of relation R1 must refer to the existing tuple of relation R2 is called referential integrity constant that you are applied to follow while designing a table. Okay, so this has been discussed in yesterday. Last class I given lot of examples for particular requirements of a database. Okay, so now I'll go with update and some transaction operation. Okay, update and transaction operation. Okay, so operations that need to be applied to database, Okay, some of the operations that to be applied for database for insertion, deletion, and updation of a database Okay, first let's consider a table of database. It is employee, contain SSN, name, age. Okay, then some D number, salary. We go is salary and D number. Okay, and D number. Then I have department, so D number, D name, then SSN. Okay, then there is a project, so P number, P name, P location, and D number. Okay, so then I have dependents. So in dependents I add dependent SSN, dependent name, dependent relation. Okay, so then I have works on SSN, okay, works on SSN, then P number, then hours. Okay, this is a set of tables with a primary key and foreign key for an company database, So now I want to think about update and transaction operations can be applied for an company database, okay. So here one transaction, when you go for insertion there is one transaction, when you go for updation there is one transaction, then there is deletion, there is a one transaction, okay. So that is called a transaction operations to be applied for database, Here before I going to apply for and tables or want to build on for tables for company database, first you want to think about the constants, the rules that what we'll learn with the key constants, the entity integrity constants, referential integrity constants can be applied for this table, okay. So now I'll take one table, so which is to be required while, so that I can go with a little bit broader table, so that we can insert some more values of insertion, So table will be represented for employee database. It will be like this. Okay. We have table called employee. What? SSN, name, age, salary, and D number. Okay, maybe. So this is the table. These are the attributes. I need to insert tuple. Right? We have a syntax. For insertion of a tuple. We have insertion of tuple that we contains. Okay, for a particular requirement. Okay, for a particular requirement that has been built. Told I was built and table with the attributes specified. I need to go some insertion of attributes, insertion of tuples, insert into employee values. It is a syntax to insert a tuple in a relation through SQL. Okay, so insert into employee values. So here are some attributes. Okay, first I will insert SSN with specified varchar, that is 11 as a unique key, then name, maybe I will give SS, then age 24, and salary, okay, then department number 1. Has been inserted. Okay, I must have other table, that is department table. It may be look like this. Okay, so department table with D number, D name, and SSN. Okay, so 1, 2 are the two departments that it has. Okay, so let us finish this one. At that point we can go for department. So insert into employee values. Okay, I have inserted with the 11 as 24 and 1000 salary with the department number 1. So insertion of 11, it's a primary key. Then name, then age, then salary, then department number. Have been installed. So here as I told, it's a primary key, it's a foreign key. So department number is a foreign key, right? So when I insert 1, so when I install that, you are inserting a particular employee as a unique key specified with 11 is going to be name with the SS, age with the salary, department number 1. This department number 1 refers department table, right? This one is must be exist. When I go for insertion, this one department must be exist in a department table. That is, you are following referential integrity constant. Then you are following and referential integrity constant. Like a 1, it is there. So maybe CS, maybe this SSN, what I am referring, must be exist here, because it's again foreign key that refers employee SSN table. If I tell that it is belong to 11, 1. So manager is 1 1 for a department table, Next I will insert, if again it's 1 1 with BB with 24 with some 2000 with demand number 2. Okay, so what I done here, I'm going for insertion, I'm going for insertion again, right? I'm going for an insertion again. Okay, so here I'm inserting 1 1, again 1 1 I'm inserting here. I'm inserting 1 1 with the names different, age will be same, salary will be different, and department number will be different, but the primary key will be same. There is a duplication of primary key, right? Because again if I insert 1 1 here, it does not contain uniqueness property. As I told, primary key is the one thing that uniquely identify a tuple in a relation, right? Identify a tuple in a relation. This 1 1 is cannot able to insert. You are violating what you call entity integrity constant. You are violating an entity integrity constant. Okay, so this is again duplication is not possible because you define primary key as a SSN. So SSN cannot be duplicated. This 1 1 cannot be duplicated. There's a rule has been defined. That rule has been defined in entity integrity constant. Okay, so if I tell now different to 2, then it must be. Okay, so for a while I'll make it 3. Okay, so 2 2 2 it will be inserted because of it is uniqueness property. Then BB 24 2000, so I told 3. So there is a referential integrity constant that you are following, that department number refers department D number, but in D number I have only 2 departments. But I have given 3 here. So 3 is not able to insert because 3 is not the department number. There is only 2 departments. There is 1 and 2. There is no department number 3. Okay, again you are violating referential integrity constants. So it must be, this must be 2. 2 or 1, that's what the department exists, must belong to department employees, can be specified. So 2 with a B 24 2000 and whatever salary and with a belong to department. So now it will be inserted. Okay, so this is the way of insertion with some rules specified as entity integrity and referential integrity for insertion transaction operation. Here you want to check with entity integrity and referential integrity. Okay, so now I will go with other operation, that is update operation. So update, which table you need to update? It is syntax I am referring for SQL. Okay, so when you practice the DBMS lab, you can see that how the tuple have inserted. Maybe the teacher who taught you DBMS lab, you will surely tell that how to insert a tuple, how to create a table, how to alter a table, how to drop a table, how to insert a tuple, how to update a tuple, how to delete a tuples from a given tables with a database. Okay, so update employee, the table which need to be updated. So update employee. Okay, set salary is equal to salary into 10. Okay, where SSN is equal to 111. Okay, this is syntax. So I am updating employee where salary is incremented by 10 into 10. Okay, then where SSN is equal to 11. So particular employee for called SSN with a unique key specified with 111. I am going to increase salary with 10 rupees extra for in a employee table. So it is surely execute, right? Surely it executes. No issues in it. Successfully it is executed because now I am following all the rules that specified. I am following all the rules that has been specified. So now I'll update the department table. I'll update the department table with employee table specified. Okay, so set D number is equal to 3, where SSN is equal to 1111. Okay, it is possible to insert, it's possible to update, sorry, possible to update, right? No, not possible, right? Because update employee set department number is equal to 3, where SSN is equal to 1 1. This is SSN 1 1, but update is equal to 3. If it updates, if it go for updation, then there is no department number 3. There is no department number 3. You are violating a referential integrity constant in update operation. Okay, so that is not possible. That is not possible to update with specified SSN for department number 3. You required update only 2 departments, that is 1 or 2, because in department table there is only 2 departments, that is 1 and 2. Okay, so if I specify 2, surely it executes, surely successfully it executes, So this is nothing but an update operation. Okay, so now we will try for other constant that will be followed. Okay, so I will tell SSN is equal to, so I will specify change department number 2. So SSN, update set SSN to 3 3 3. Okay, so I am giving so update SSN with a 3 3 C for the department number is equal to 2. Wherever you find department number is equal to 2, change SSN, change the SSN. Is it possible? No. Once you define the primary key, once you define a primary key with uniqueness property, you cannot update. Once I join a particular organization, so there is ID for everything, right? This ID is a unique ID. My ID cannot be given to other person, right? Cannot update my ID because it will be fixed. So once you join institution, it is fixed, right? So primary key cannot be updation. Go for updation. Okay, cannot delete the primary key or cannot keep it in null. Cannot go for updation. So this is not possible because primary key is already defined with 1 1 1. So you cannot go for updation. You cannot go for updation of a primary key, that is SSN with a 3 3 3 is specified, right? So wherever department number 2, you cannot go for updation of this. Okay, you cannot. Once you define, it's closed. Once defined, it has been closed. Okay, you cannot violate, you cannot change the primary key. Okay, that is one of the defined with the entity integrity constraint. That comes with the entity integrity constants. Okay, so that is what the property of primary key is defining. The property of primary keys can be defined that you cannot change primary key once it's defined. Okay, because rule has been applied here. You are following a lot of rules, so I cannot change. Okay, so this is update operation with the referential integrity constant, entity integrity constants. Okay, if I specify null here, if I tell put null value here, so put null value where department number is equal to, it's not possible because primary key cannot be null. That rule is defined by primary entity integrity constant. That's what you cannot go for updation of a primary key. Okay, so this is one type of things that it to be considered while going for updation. Okay. Then there is other operation, that is insert. Delete operation. You want to go for a deletion operation. Okay. So first one. So let's use other tables. We are using only employee and works on employee and department table. Now I'll try to use works on table. So delete SSN from works on table where P number is equal to 2. It is works. So I am deleting SSN in a works on table, that is here. So here both are keys. Okay, which refers the primary key of employee table, P number refers to project table. Okay, so works on with SSN I want to delete out with the P number is equal to 2. That is defined with the works on table. Surely be deleted, right? Surely it will be deleted, right? It's not the keys refer from, because I am an employee working on a particular project, my details are in the employee table. So if I delete here, no problem. You can delete it out. Okay, you can delete it SSN in a P number easily. It works successfully. All the rules are following. It works well. Okay. So now if I tell, so delete SSN from employee, from employee, from employee, from employee where D number is equal to 2. So now it's possible because you are going to delete a primary key. Is it possible? It's not possible because you are violating the conditions, which is not possible. So cannot, once you define, you cannot delete because you want to go to delete only through on delete cascade. You cannot go to delete like this because this employee table, the SSN what you are using, it refers by department SSN, it refers by dependent SSN, it refers by works on SSN. So it's not easy to delete in a single table. When you're going to delete a particular employee quits the organization, then you make sure that it will be deleted from the details of what's specified in SSN. It must be deleted from department table. It must be deleted from dependents table. The information of that particular employee will be deleted from works on table. So all the details must be updated. All the details must be updated. Okay, such a way the system has been built. Such a way the system has been built. Right. So when you go for delete this SSN, make sure that you use on delete cascade. This operation specified in the lab, that is there is on delete cascade, where when you delete here, when you delete the SSN here, it must be updated, deleted in SSN. It must be deleted in dependents. It must be deleted in works on table. Okay, like this. That's the way the possibility of deletion of SSN is possible when you operate rules of on delete cascade for all the tables. For all the tables. Like that you one can delete. Like that you can delete a particular employee from an employee database table. From employee database table. Okay, like this it's possible. Like this it's possible. Okay, so this is what the information is. If I go for delete the department table, make sure that when you delete when you remove the branch from a particular organization, make sure that all the employees will go for updation of other departments or quit the department, right? So when you delete this particular department, so make sure that the employees belong to the particular department must be deleted, because there is no department. How can you go for maintain the employees, right? So when you delete this, it must be automatically deleted. It must be an automation of deletion is possible in a given scenario. In a given scenario. So this is talks about initiation operations with a transaction specified. Then there is updation operation. You want to follow entity integrity and a referential integrity, right? Then there is a delete operation. While deleting, you want to maintain on delete cascade with referential integrity constant and entity integrity constants to define with insertion, deletion, and updation operation and operation. So here I given small introduction of this. When you go for lab, when you go for DBMS lab, you can see you do lot of operation because the people who actually go for insertion of a huge number of data to a particular table and doing a queries, right? Because you do a lot of queries in a DBMS lab. So there will be a lot of insertion, a lot of deletion, there is a lot of alteration. So everything is people are doing, right? So it make more practices while going for a DBMS lab. When I go for given for small introduction here, but I will load lot of work the people will do in a DBMS lab. Okay, because without insertion, deletion, or updation, it's not possible to do a DBMS lab. DBMS lab. That's what more practice. So you are given a small introduction of how the transaction can possible while following entity integrity and referential integrity Okay. So now, so this is about the transaction that can be operated for database schemas. Okay. So now I'll move to relational algebra. So now I am actually moving to the core of requirement of the people of a queries in a DBMS database management system. So it's more required, it's more specified, and most things that is to be queries. So query DBMS means queries, right? DBMS means queries. So you must learn queries well. So you must follow, you must see interesting things as that DBMS comes with the queries. The first one, we have two types things that we discuss in RDBMS. That is, one is relational algebra and the one is SQL. So I start with relational algebra is the first part. So relational algebra. Relational algebra. So one of the things is the fantastic thing, because of algebra, because we're using all the mathematical symbols to do a query. That's what they're given. Applying algebra with a mathematical to database with the various symbols specified and do all the operation of basic operations of a mathematics to a relational database, Okay. So here the definition is a set of operations that use it to manipulate the entire set of relations. So a set of operations that use it to manipulate entire set of relations is called a relational algebra. Okay, a set of operations. I told a set of operations that use it to manipulate the entire set, if I consider a table of what I call company database, then I think of talking about employee table, department table, project table, works on table, dependent tables. So entire set of relations can be applied with a set of operation that is called a relational algebra. That is called an relational algebra. What is the set of operation? I told and set of operation. What is a set of operations? So here set of operation is select. Okay, go for projection. To retrieve, we go for projection. Join, divide. Okay, join, divide, rename. Join, divide, rename. Select, projection, join, divide, rename, union, difference, intersect. So all these operations applied on the relations. So all these operations applied on the relations, it give new relations. It give a new relation. Okay. Apply selections on a particular relation table, you will get a new relation again. Apply projection symbol to a database, to a tables, you will get a new symbols. Apply join operations, join two tables, get a new relation. So divide, rename, union, intersect, and go for difference. So these are some of the operations. This aggregate, there is a group by. Okay, some of the operations that can be applied for a huge number of relations provided by DBMS or provided by database to manipulate. Okay, so this is called relational algebra. This is called a relational algebra where defines with tells that a set of operations, all the selection, projection, join, divide, rename, grouping, aggregating, then union, difference, intersect, all these operations can be applied for entire set of relations to get a beautiful relation again. We can use a relational algebra. Okay, that is called a relational algebra. So in this, ask a question, what is a relational algebra? You can tell that a set of operations that use it to manipulate entire set of relation is called relational algebra. Examples are selection, projection, intersect, union, difference, grouping, dividing, Cartesian product. So all these are possible in a relational algebra. Okay. So first, let's start with the first operation, that is selection. Okay. That is selection will be the first operation in a relational algebra. Okay. So first one is selection. Represented by represented by sigma symbol, represented by sigma symbol. Okay, represented by sigma symbol. So here selection symbol, sigma representation. The definition of selection symbol is very simple. It selects subset of the tuples. It selects subset of its tuples which satisfies the selection condition. Which satisfies the selection condition. So it is nothing but it's select subset of tuples. Subset of tuples which satisfies the selection condition, which satisfies selection condition, which satisfies the selection condition, which satisfies and selection condition. Okay, so it selects a subset of the tuples will be selected, and you can select subset of your tuples, a small set of your tuples from a huge set of your tuples, which satisfies the selection condition, which satisfies the selection condition. Okay, the symbol is very simple. You want to represent like this. Okay, sigma symbol, then condition. What the condition you are putting up? What the condition you are putting up? From which table? From relation. From relation. From a relation. From a relation. Okay. So, you are putting selection condition with a relation. With which table you are taking from, what the condition you are putting, and what the relation you got. What relation output you got. Okay. It select subset of your tuples which satisfies the selection conditions with syntax represented with sigma symbol condition from which relation, which gives a new relation, which gives a new relation. Okay, which gives a new relation. So previously I talked about the employee database, right? Our company database, what we ask. There is an employee, there is a department, there is a, what do you call as, there is a works on, there is a project, there is a dependence table, right? So I'll take a small example of that database, because it's a process of, as I told, it's a process of taking employee database as a best example to do all the queries or to all the give the examples that can be go with the DBMS. Okay. So here I'll take two tables. I will take two tables. One is employee and department. So employee containing SSN, name, salary, gender, and D number has been specified with department number, with department table, with D number, D name, and SSN. So this is the table you can use for as a doing the small example of selection condition, small example of a selection condition. So here I'll give one question. So find the tuples where, or find the employee tuples whose salary is greater than 10,000. So find the employee tuples. So I'm telling about find the employee tuples. So employee tuples whose salary is greater than 10,000. Whose salary is greater than 10,000. So you can see that there is a salary. There is a salary attribute in a employee database. In a employee database. I'm telling people to requesting means I told a question that find the employee tuples whose salary is greater than 10,000. Whose salary is greater than 10,000. You want to find the employees whose salary is greater than 10,000. So here I am putting salary as an attribute taken from employee table. Taken from an employee table, right? So condition is where salary is greater than 10,000. Where salary is greater than 10,000. So salary is greater than 10,000. Okay. So salary is greater than 10,000 from which table? From which table? That is employee. That is employee, right? So I'm writing relation, condition, and R1. So R1 contains the employee names, SSN, salary, gender, and department number whose salary is greater than 10,000. Whose salary is greater than 10,000. Whose salary is greater than 10,000. Right? Very simple way, right? Very simple way written, right? So seeing that relation R1 contains the condition that salary is greater than 10,000 from employee relation specified condition stored in R1, relation R1. Okay. So this is one selection condition can be applied for retrieving a query called find the employee tuples whose salary is greater than 10,000. There is other question that I will ask. Okay. So find the employee tuples who work for department number 2. So find the employees who work for department number 2. So here I can tell that, here I can utilize which attribute I want to utilize to retrieve the employees tuples working for department number 2. So here there is a department number, right? In employee table they contain department number. Here department number. These two, there is no relation for employee, right? There is no employee details in a department table, but there is a department number which contain all the employee details, right? So I want to retrieve the employee tuples whose work for department number 2. So department number 2 is here. I can retrieve the employee values. Right? So here I can give a new condition, that is retrieve the employees who work for department number 2 from employee tuple. That is R2. Right? I give a new condition. That sigma that, so department number 2 from employee specified relation is R2. Right? R2 have been specified. Right? So R2 is relation name that contains the employees working for department number 2. Right? Employees working for and department number 2 has been given. So employee number department 2 has been specified with selection condition. Then I'll give other question. So find the employee tuples whose salary is greater than 10,000 and works for department number 2. Right? So I'm given a question that find the employee names who work for department number 2 and the salary is greater than 10,000. Okay, this is the question I'm asking, right? It's a question arises in my mind while thinking about employees. So I require the employees working for a particular department, what means which department number they are working for, and salary must be greater than 10,000. Okay, two conditions have been specified. One is department number 2 and salary is greater than 10,000. So what I want to do it? How to write that? So first I will go for relation R1 specifies. Okay, so R1 condition that department number 2 and department number 2 and salary greater than 10,000 from employee table. So I utilize the logical condition, that is and. Okay, and I told that so R1, so the department number 2 and salary is greater than 10,000. So two conditions I told, find the employee tuples who work for department number 2 and salary is greater than 10,000. I given a condition from a table called employee, and employee table have been specified. So here I am telling that employee table number 2 and salary greater than 10,000. All the tuples, the R1 contains the employee working for department number 2 with and also salary is greater than 10,000. So whose condition, both the condition works, both the conditions true. If you can given R, any one condition possible, but I given and, so you can give R also. So I am given and because the question is and, right? So department number 2 and salary must be greater than 10,000. Then I retrieve the employee tuples. Okay, so this is the way the selection condition works. This is a simple way the selection condition works. Okay, so then I also have another question. Okay, let's go for project table. Let's go for the project table, right? This other table, the project table. It's fantastic requirement things is considered to be with project table, because only employee and department of things is not good enough. So also a little bit tricky. We go for project table also. Okay. So find the tuples. Find the project find the project details controlled by department number 2, controlled by department number 2. So you want to get a project details, project tuples controlled by department number 2, controlled by department number 2. That time I can write for a simple way, I can write simple way, taking off. So R1 is a relation, tells that department number 2 from project table. So R1 contains the project details controlled by department number 2. So R1 tells that R1 is here with the specified selection condition the department number 2 from project table retrieves, R1 retrieves the project details of department number 2. Project details of department number 2. Okay. So this is a selection. This is what the selection condition speaks. Okay. So this is what the selection condition speaks. So then we move to let's move to project table. Let's move to a projection table. Projection table we move to, because projection plays major role. Projection plays major role for selecting a set of columns. So projection, that is pi symbol. So projection we call as projection, that is pi symbol. So it is used to select set of columns in a relation. Select set of columns in a relation. Syntax is very simple. You can write A1, A2, AN from a relation, that is R1. You can give R1 or not. So it is nothing but so pi symbol goes with selecting attributes, selecting a set of columns from a given relation. So A1, A2 till AN, set of attributes will be selected for a given relation. R1. So selecting a set of columns from a relation. Okay. So that is called projection. Projection. Example is find all the name of employees. Or retrieve all the name of employees, or retrieve name and address of all the employees. Okay. For a simple way, retrieve name and address of all the employees from a table relation, that is R1. So R1 contains name and address of all the employees. So I can say that. So name and address of all the employees will be retrieved. Okay. So this is one way of going projection. So I am selecting only set of columns. Or I will ask other question. Retrieve the salary of all the employees. So I am not specifying any condition here. Just I am telling retrieving only columns. So retrieving salary of all the employees. That has been done, right? Right. So this is what the simple column retrieval. I can give other question. So retrieve the project name controlled by department number 2. If I give that, then I want to go for condition. If you retrieve the project name of a project number of a particular project names, I can go for projection. If I did get any details of all the projects, we can go for, then I can apply again for a selection of P number and P name from project. Okay. So here P number, so P name from project. So this is one of retrieving simple way of project number and project name from project table to get the details of only project details of a things that required for any given specification. So this is what retrieving only columns from a particular table, okay, particular table or from particular database, okay. Now I will make other little bit combination of selection and projection for a given things. So I combine the selection and projection condition retrieving columns from a given relation, okay. So retrieve all the employees, names who work for department number 2, okay. The question is very simple. So retrieve all the names of the employees who work for department number 2, okay, So retrieve all the names of employees who work for department number 2 from the employee table, So R1 gives the combination of selection and projection that tells that put a condition, retrieve a columns from a relation and give to other relation, okay. So name I am retrieving who work for department number 2, condition specified from a table called employee given in a relation R1. So R1 contains name of all the employees who work for department number 2, okay. So like this you can go for combination of a particular things. And now I will give you another question. Retrieve the project name controlled by department number 2. Retrieve the project name controlled by department number 2, okay. So name, condition from which table? From project table, that is R1. So name of the project, so I want to give P name. So P name of a project, tables details will be provided controlled by department number 2, So I can specify like this. So P name condition specified from a project table, D name number, P name is retrieved, R1 contains details of P name of a controlled by department number 2, So like this you give combination of selection condition with the projection symbol, make a database beautiful, right. You can also retrieve, find the employee names or find the SSN of employees or SSN of female employees, you can give it out, okay. The time I can give like this. So find the female employee details, So find SSN of a female employee details. So gender is equal to female from employee table. From which relation? That is from employee table given. So R1 contains SSN. Applying condition called gender is female. So female SSN retrieved from a employee relation contains in R1. So this is what a simple projection, selection, and what you call as combination of selection projection work for a relational database. Okay. So next class I will continue with union, intersection, and Cartesian product with intersect. Then I go for working on joints. One of the fantastic things is we started with selection and projection. Later part we have some more symbols, very easy way to represent a beautiful representation with the company database. Okay. Thank you so much.